I'm going to have some highlighters here as well. So make sure you follow along. Page 64, compass direction. So in this scenario, I honestly would like you to first read and then look at this. This is me setting it up for you, right? So we can kind of, we know that there's straight lines, everything like that is there. So a hiker starts walking east, 30 north. It's extremely important that you know how to start this. So you got to go from the east. This is east right here on that line, and then you measure 30 going north. And so that's the 1.8, right? Then turns in the direction south 50 east. So you got to watch out. This is your south line. So you start from there and then you go eastward like that. So the 50 is just in here in that little wedge here, not touching the side that you came from, all right, guys? A lot of times I see the whole thing being 50. That's not accurate. It has to do with a compass rose, okay? So we've got the 30 there, we've got the 50 there. It does tell us that this stretch here is 1.1, okay, so we've got that figured out. Let's bring some angles, let's make some angles up here, okay? This 30 here is touching the east line. This is also the west-east line here. So technically we could do this, right? This is 30 using alternate interior, that property. And, oh yeah, so what is this going to be here? If this is 30, then this is 60. Yeah, a lot of it can just use mental math, right, all around. So this is 60, which means that this whole thing is 110. Yeah. So you kind of have to use the angles that I gave you to kind of move them over to one place, and then use what you know about angles. That there is a 90 here. There's another 90 over here, right? And so then you can start filling in what's missing. Okay, so now you could start your clean triangle. And I want to mention this, okay? If that's why I wanted this on the computer. If you were to draw a line like this and complete your triangle, you should see that the 30 is cut. Okay, so you cannot bring the 30 over to your clean triangle anymore, because the clean triangle doesn't have the compass rose, right? So you take that, right? You take that one, and just try your best to copy it. It's going to be easier for you to solve if you actually make it look somewhat like it should. And by that I mean the angles in particular. Okay, so this would be your S, T for turn, E for end. You can use whatever letters you choose. I don't really care. Okay, and I'm not going to solve here. I'm just going to set it up. So the only angle that comes with you is this 110 that you figured out. From end to end is 110 degrees. And that would be cosine law, right? So that one is actually not too bad to solve. Okay. Next, let's go to 64, number 2, question 2. I posted the key to this, so solving is kind of like up to you right now for today's AC. So let's forget about this first, right? Just read. Eric leaves the dock. So this is the dock technically. I can put that down. In the direction north 40 east. So you got to make sure you start from the north line, right? And then you go 40 degrees eastward like that. So that's the 40 here, right? So you travel and then you turn, right? Stops to explore, then heads out in the direction east 15 degrees south. So this is east. This is your east line. So you kind of put your pencil on there and then you turn towards the south, and it's 15 degrees. It should be a small angle, not a very big one. Okay, and that's 22.34 kilometers, and then you end. Okay, so this is your scenario, this is your interpretation, and we're told that the cabin is 47.13 kilometers away from the dock. So this is your cabin, the end, right, and this is your dock. So this is the distance we're told. So keep in mind, okay, watch carefully. We were not told how far we're traveling on our first leg of this journey. This is the first leg. This will be the second leg of the journey, right? So we don't know what this is, so that's kind of interesting. But we can do it. And then when you close your triangle, I shouldn't have closed, well, I had to close it because of this information, but, right, you notice that the 40 should not come in this corner. That is the most common mistake, that the 40 somehow comes into the clean version, and it makes it very easy to solve. Like you'll have like sine law, cosine law, whatever you want, you can do it, and that's not going to be true. So what do we do with that 40? It's touching the north-south line here. So it will be touching the north-south line if you bring it over. So this 40 crosses the, what do we call this again? The transversal, right? And so here you've got the 40 appear inside the big triangle. And with this 15, you'll figure out that this is 75, right? Because you've got complementary angles here. So we're going to go 90 minus 15. Maybe you want to add this to your notes. Right, that's how I came up with that. And this is just alternate interior. Right? That's how you came up with that. It's going to get too busy if I add that up there, so I'm just going to leave it. Okay, please show me what you're doing. So now we're going to do a clean version here. Okay, so I'm going to copy that. So this is the dock, this is the turn, and this is the cabin. Or what's the first stop? Island, sorry. So it's a turn, right? You're changing direction, but you can also call it an island if you want. It's probably better to use the wording within the problem, right? This is the generic start, turn, end. So we know that this is 4713 kilometers. This is simply going 40 plus 75, and that's 115, right? So this is 115 degrees there. This side right here is 22.34 kilometers, so that's your clean version there. What law are you going to use, if any? You've got a pair here, right? Angle and side across, so it's sine law. What is it asking for? Calculate the distance Eric traveled from his dock to the island. So we want to know this here. This is our unknown here. I'm going to call this x. Okay. Can we solve for it right off the bat? You cannot, because this is sine law here. This side is going to allow you to solve for that angle, angle D. Once you've got two angles, you solve for the third one using sum of triangles. Then you have to do another sine law to figure this out, or cosine law, whatever you want, because once you know this angle, you can use side, angle, side, right? This corner using cosine law to solve for x. So it's up to you how you want to solve it. Okay. And the key is posted. I don't have it in front of me right now. But it's important that you don't bring the 40 in here, or even the 15. I don't know. I've seen it all, right? I've seen a lot of it. So just be careful. Use a ruler, please. Okay? Let's do 4, and then I'll call it quits. And then you'll show me how much you know. So page 65, question 4. This is almost like a rare oddball out there. Kira drives down a road due south, right? So when it doesn't give you degrees, it's just due south, you're going straight down, okay? So we start here and we're traveling along this, in this direction, obviously. And it says that she notices an island on the lake which is next to the road at west 34 degrees south. So this is my west line, so 34, so that's where the island is located, okay? And then she travels due south 40.2 kilometers. So it's just traveling 40.2 kilometers this way, and that's where that side comes in, okay? She looks back to the island. So there's a point where if this is your island, because of the wording, you're wondering, is it here? Is it here? Where is she looking at the island, right? Because it's looking back, you have to go past it. That's one hint, that's one clue. And also the compass direction is also going to give it away that you must be past it, right? So I was very specific there. North 71 west. This is your north, so you go 71 degrees west, right? And so this is the scenario that appears here. It says calculate the distance between her second location. This is the second location. This is the first location. The distance between second location and island. So this is our ultimate. That's what we want to know. Okay. So how can we solve here? You might think it's impossible, but this 34 actually is going to help us figure out this one inside. Okay. You can actually just go 90 minus 34. Because there's a 90 formed here, and you're actually, listen to this one carefully. This is the south line, north-south line, and you're also traveling on it. So it actually is one of the sides of the triangle. Okay, so you can actually use that. Okay. So 56, right? 56 degrees goes in there. And you might still think it's not solvable, but you can, right? Like these two angles will give you the third one, and then you have a pair, which is sine law, right? If you have a hard time thinking pairs, think of it this way. Cosine law only works for side, 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 right? All three sides, not it, definitely not it. Side angle side, side angles, you need two sides and the angle in between, right? You only have one side, so you're stuck. You can't use cosine law here. It has to be sine law, right? So you just have to find angles. You found this one, which in turn will help you find that one, and then it's just a ripple effect, and you go ahead. Let the marks for the questions tell you how much work it is. If it's like a 5-mark question, sometimes it's 5 marks. It's like diagram. Maybe you have to do sine law once and then sine law one more time. Okay? So that's going to help you out. Is today going to go smooth? You're going to ace it? Probably not. Maybe you'll prove me wrong, right? But you have to get your feet wet. Like you can't just be like safe, safe, safe the whole time whiteboards. Like you have to actually like, can you do it if I put it in front of you by yourself, right? So